Hello, and welcome to Physics World, where you will learn all you ever need to know in the existence of human knowledge. On this episode, you will learn about energy and all the beauty that comes with it. We will be covering thermodynamics and basic collisions today. Energy in physics is initially almost always labeled in three different forms. Gravitational potential energy, that's what makes stuff fall. Kinetic energy, that's what makes stuff move. And potential string energy, slinkies. But all energy in the universe follows some basic rules, one set of which is known as the law of thermodynamics. For the next examples, we will be ignoring spring energy as it does not add any knowledge to the understanding of the rules. First, a description of the vocabulary that we will be using. Gravitational potential energy is the energy that is derived from the force of gravity along with height. This is the reason for objects falling or sliding down hills. For the sake of AP Physics 1, this potential energy is usually converted into kinetic energy. The equation for UG is mgh, and the equation for kinetic energy is 1/2 mv squared. Now, kinetic energy is quite literally the movement of an object, as it is the result of velocity multiplied by other variables. The first law of thermodynamics is as such. Energy cannot be created nor destroyed. Energy can only be converted into different forms. This is also known as the law of conservation of energy. Simply speaking, all the energy put into the system will be the total energy at the end. This can be seen in a very simple diagram in which a ball rolls down a hill. Because the ball is high up and goes downward, it has gravitational potential energy. And as it decreases in height, the potential energy is converted to kinetic, so that at any point, kinetic plus gravitational energy are equal to each other.
Another example is when a ball, instead of just rolling down the hill, it will collide with another ball at the bottom of the hill. This will lead to a collision between the two balls. In a perfectly elastic collision, the energy will be conserved between the two balls. However, there is one upsetting law that stops all energy from being conserved. This one upsetting law being the second law of thermodynamics. The second law of thermodynamics is that energy will not be lost in a system of two or more objects. However, in the overall system, energy will be conserved. This leads to work in this. Now, what is work? One may ask. Work is force times distance, and is the energy lost in the system. This system comprising of both the two objects. These forces can be friction, air resistance, or any other force that could cause energy loss, maybe like an applied force. These energies typically can be expressed or observed as heat.
A common myth that relates to energy is the perpetual motion machine. Robert Flood's 1618 water screw perpetual motion device is widely credited as the first recorded attempt to describe such a machine. This machine would have water pouring down onto a water wheel that would then move an Archimedes screw, which pumps water back into the tank. This machine wouldn't work in practice because the energy that the water wheel provides to the screw is less than the energy spent by the screw pumping the water back up. So eventually, the system would run out of energy.
And that wraps up our lesson for today. To review, there are two laws of thermodynamics. The first being energy loss, and that energy cannot be destroyed or created, but it's always used. And the second being that in a system of two objects can lose energy due to work. However, in the overall system of energy can be conserved. They involve energy which is seen in the forms of kinetic, potential, and spring energy. These energies can be expressed in LOL diagrams and can be seen in the examples with the balls as shown in our earlier work. Finally, a perpetual motion machine is also impossible due to these laws that energy is always going to be lost and energy will always be conserved. However, and that wraps up our lesson for today. I want to thank you guys for watching. Make sure you smash the like button and subscribe here for more content, and here's a lookout for our next video next time on Physics World.